Hey everyone, so today I will be solving a LeetCode hard problem, IPO. So like a long story about LeetCode's IPO is given here. So I will just explain you the problem statement in short. So we are given an n projects where the ith project has a pure profits of I, and a minimal capital of I is needed to start it. So what we are given is we are given a projects array as well as a capitals array. Now that means we have n projects, and now we need to do? We need to means if we are want to start a particular project, then we should have a minimum capital of I, and along with that, if we start that project, then we'll be earning profits of I profit. So initially we have the W capital. Now we are allowed to start at most k distinct projects. Okay, and out of means we have n, and we can start k distinct projects less than or equals to n, such that we want to maximize the total profit that we'll be getting. So such that at each step, when you try to read the problem statement, you might think like if we are able to, like if we have the capital to start a particular project, then we might use this capital and then earn this profit. But this is not the case. So that's why I have written this goal separately here. So we want to select at most k projects to maximize final capacity W, final capital W. Now a project I can only be started if the current capital W that we have is greater than equals to capital of I. And if it is greater, then we will not be using this capital of I to start the ith project. We'll simply means start the project, and the new capital that we'll have will be W plus profit of I. Hence, capital will not be consumed, profit is added. Okay, so if you like will not means clearly understand the problem statement, you might think like you will first use the capital and then earn the profit, and you will head in the wrong direction obviously. So this is like this maybe you might get confused in the problem statement. That's why I have written this goal separately. So I hope the problem statement is clear now. So let's see like for the given example. So initially we have the capital as 0. Okay. So from 0 capital, how many like projects can we start? So we have 3 projects, 0, 1 and 2. Now we see only one project has a capital 0, means has a capital which is less than or equals to W. Only one which is 0. So hence we'll be using starting this project, and our W will become W plus 1. That means W will become 1. Now we have made this k as 1 now. We have started one project. Now we can start one more project, at most one more project. So now the capital is 1. So we will see like how many projects have capital required less than or equals to 1. So we see there are 2 projects who have the capital as 1. Hence we can start both of these projects. So which capital will be, means which project will be starting? The project will be starting which provides us the maximum profit. Since this 3 provides us the maximum profit, hence we will be starting this second project. Initially we did this first 0th project, and now we will be doing this second project. So the overall W becomes 1 plus this 3. So hence it is 4. And now this k becomes 0, and hence since we can only start at most 2 projects, hence we started 0th and second projects, and we earned 1 plus 3. Initially W was 0, so hence W finally becomes 4, and this is what we need to return, the maximum, like return the final maximized capital. Okay, so hence the output here is 4. Let's see a different input. So we have k equals to 3, and again initial capital that we have is 0. So we'll see like since this 0th project has a capital requirement equals to 0, so we can start this project. Okay, so this W now becomes 1. We'll add this profit to W and it becomes 1. Now we'll see like the first project that we have has a capital requirement of 1, so we can start this project. So the new W will become 1 plus 2 equals to 3. Okay, and now we will be able to start this project as well, since it has a capital requirement 2 only. So we'll add the profit of this also. Since this k equals to 3, we can start all of these projects if the capital required is feasible. So 3 plus 3 will become 6. So hence we can start all of these 3 projects in this case, and hence the output here was 6. So what do we observe? If we have the current capital as W, we need to identify all projects with capital of I less than or equals to W. Right? The first step is to identify those projects who have a capital requirement of less than or equals to W. Now once we identify, so suppose we get a set of projects like I1, I2, so on till IM. Suppose we get M projects which satisfies this condition. Okay, so now which project will be starting? We'll be starting the project which has the maximum profit, obviously, because at each step we'll be increasing this W by the maximum value. If it is increased by the max value, then we'll be able to start newer projects maybe, and with newer projects which has more profit involved. Okay, so currently identify we all those projects which have the capital requirement less than or equals to W, and then we'll identify the from all these M projects, we'll identify the project with profit of I as maximum. Okay, and once we identify this profit of I as the maximum value, we'll update our W with W plus profit of I. Now when this W will be updated, again we'll do the same. Like identify all projects with capital of I less than or equals to W. And since this W is updated, then this set will now increase. It will be increased and it will include more projects. Right? Okay. So this will we'll follow this till we have used K projects. Started K projects. So we'll follow this approach till we have started K projects. So as you can see, the first step is to identify all projects with capital of I less than or equals to W. That means if somehow we sort projects on basis of capital, and we now this is the capitals array. Now we put an index at the start, okay, and we have the W as something, so we can move this I to identify the projects whose capitals are less than or equals to this W. Okay, so we'll be able to get the set. Now if this W becomes W dash, then we'll simply move this pointer more ahead to identify the new set of projects that we can start. Right? So sorting the capitals is the first step. We should it should come into our mind. Now how will we removing the projects? How to remove projects already started? One problem is this, and another problem is how to find the project with max profit. Okay, so now once we have identified that this range of capitals, this range of projects we can start, then we need to identify the project which has the maximum profit. Right? Now we see that currently means the N and K, means K can go up to 105. Okay, and N can also go up to 105. So this capitals array length can go up to 105. Okay, so hence if we first identify the range of capitals, and then once we have the range, we try to find out the project which has the maximum profit, and then remove it from the array. So it will obviously take n square and it will not be feasible. Okay, so what do we need to do? And as well as we need to remove that project from the array as well. So maybe we can use a set. Okay, so since set will be storing the values in the sorted form, so the value present at the end will obviously denote the maximum profit, right? And hence we'll update our W with this maximum profit and then remove this profit from our set. Okay, and then again the updated W will move this I forward, hence this set will be updated. So the first step was to how to find the project with max profit. So to find this, either we can use set to find the means currently of all projects which project has a max value. So we can either use a set or we can use a priority queue, max heap. Okay. So since max heap is like a more popular, so I will be using max heap here to like it will give us the maximum element in big of log n, where n is the size of like priority queue. Okay. So we'll be able to get like we know like the maximum number of projects that will be pushing in priority queue will be n, and n can go up to 1e5 only. Hence, we will be able to get this max element in log 2 of 1e5, which is simply like around 16 to 17. Okay, so we'll be able to get this in order of 16 to 17, and then now we need to update our w. So what we'll do, we'll update our w with this w plus max. Now when this w is updated, what we'll do, we'll again move this I forward, and while we are moving this I forward, we'll be pushing all the profits values in our priority queue. Okay, and as soon as we encounter the condition that our means we have pushed all the i's, means pushed all the capitals which are all the capitals whose value was less than equals to w. Once we have pushed it, then we'll find out the maximum profit from the priority queue and then add that to our w and again remove that from the priority queue. Okay, and we'll do this till we have means added k, means k projects. So we have till means we'll do this till we have removed means removed k projects from priority. Okay, so I hope you get the approach of the like the greedily how this will work, because obviously here means here the first step was to identify like we need to choose those capitals whose value is less than equals to w, and that hinted us like if you sort the capital array, then we not need to traverse through the entire capital to identify those projects whose value is less than equals to w, because all it will be represented by a range of values, right? If it will be represented by a range of values because the values are in the sorted order. Okay, and now once we identified it, then the next step was to identify the project which had the maximum profit. And to identify the project with the maximum profit, what we do, we simply use a priority queue which gives us the maximum element in log n complexity. And once we have the maximum element, we will simply update our w and decrease the k count, because k count will decrease, and then we'll do this while this k is greater than 0. Okay, so this is like the approach for this problem. Let's try to see the code and then you will get a more understanding about the algorithm. So we simply like create a vector of pair so that when we sort it on the basis of capitals, we are also like at each index we are also aware of the profits at that index. Okay, so we create this projects vector of pair of into a main, then at each project we will first push the capital and then the profit, so that we are sorting it on the basis of capitals. Now on the basis of capitals it will be sorted in the increasing order. Now will initially our w is equals to 0, so and this pointer will be pointing to the start of the capital. Now what we'll do, we'll see like while our capital of I is less than equals to w. So we'll see like products of I dot first is simply capitals of I. We'll see while products of I dot first is less than equals to w, then we'll push it in our max heap. Okay, and what we'll push the profit that project is giving. So we'll push products of I dot second, that means the profits of I. Okay, so we'll keep pushing it, that means we'll keep doing this till we are able to like kill the capital of I is less than equals to w. Now once we have identified, suppose these were the range of projects, now we need to find the maximum project with the maximum profit, and to identify it we'll simply find the top element of the max heap. So we'll simply find the top element of the max heap and update our w and remove that profit from the max heap. And since we have started one project, so we'll be decreasing this k count. And one more condition we need to check, like if there are no capital, means there are no projects which we can start who has capital of I less than equals to w, that means in that case our max heap has become empty. That means we cannot increase W further. So in that case, we'll simply break from the loop. Okay. So that this condition means is only executed when the priority queue is not empty. And we will do this simply till we have not started at most k projects. In the end, we'll simply return this W value, which will be updated with all the maximum profits of k projects in a specific order. So I hope like this was the approach, and as you can see, like we are sorting this, so this will take us n log n. Then we have created this priority queue. So priority queue will have like maximum values it will have will n, and each insertion it will take is log n, right? So n log n, and while popping, maximum times it will be popped is k, and since the size can be log n, so it will be log n. So hence these will be the complexity of this problem, which will be approximately n log n 1e5 into like approximately, let's say, 20. So it will be like of the order of 1e6 only, which will like definitely run in 1 second. So this was the approach for this problem. I like if we are already aware of finding out the maximum element, how will means find out the maximum element in a running range of values, then like this problem would have become very simple. And yeah, this was the approach. Let's try to submit the code as well and see like how well it performs and how much time it takes to run. And as you can see, like it runs in 66 ms because of the growing heap, and yeah, so this is completely fine and it beats 93% of the complexity. So I hope like you were able to follow the approach, and now from future, if you are ever like means stuck in a problem where we need to like find out the maximum element of a range or the minimum element of a range for a running range, means if the elements are continuously changing, and for this continuous change of elements we need to find the max element, so we'll be using max heap. And if we want to find the means the minimum element, we'll be using min heap, or you can use a simple set as well. So the starting element will be storing the minimum element and the last element will be storing the max element. Okay, so this is like the solution for this problem. I hope you are able to follow the approach, and if you have any doubts yet remaining, feel free to comment down and I will be happy to help. Thank you so much for watching.